All right, we are back again, 10 minutes done. The next question is, again, evaluate. Evaluate what? A, logarithm 6 base 3 plus logarithm 6 base 2. Now, we need to analyze this. We have got two same base logarithmic function here, and there is addition in between. Remember the law? Logarithm 6 base, I can write them as 3 times 2. So 3 times 2. That makes logarithm 6 base of 6. If these two numbers are equal, now what's the answer? The answer is 1. The next question. Logarithm 25 plus logarithm 4. Are they same base? Yeah, both of them are 10. It is not written that this way is 10. We know that, right? And there is addition in between. So I can write logarithm 25 times 4, which is equal to logarithm 100. So if logarithm 100, let's say that this is, we have to evaluate it. This is equal to x. And then what is the base here? We know that it is 10, right? So how can I write it as index form? 10 to the power of x is equal to what? 100. 100 means 10 squared. It means that x is equal to 2. So when you evaluate this, that's equal to 2. At this step, logarithm 100, all right, let's solve it in another way, evaluate it in another way. Logarithm 100, I'm not going to write it equal to x. Can I write it as logarithm 10 squared? Yes, I can. If there is power, what can I do with the power? Move it in the front, 2 logarithm 10. Now, what is the base here? The base is 10. We know that, right? The base is 10. It's not written. We know that it's 10. If the base and the number is equal, what is the result of this? 1. So 2 times 1 is equal to 2. Either you do it this way or you evaluate it this way. It doesn't really matter how you evaluate it, unless you make a mistake on the way. All right, the next question is logarithm 2 base, 20 minus logarithm 2 base 5. Bases are same, there is subtraction in between. What do? I will write it in another way. Logarithm 2 base 20 over 5. So that makes logarithm 2 base 4. So what is, let's evaluate it. That's equal to x, 2 to the power of x, let's write index form, is equal to 4. 4 is equal to 2 squared. It means that x is equal to 2. Number D. Logarithm 6 base 648 minus logarithm 6 base 3. Bases are same and there is subtraction in between. So what do? Logarithm 6 base, we divide it. 648 divided by 3. So that makes logarithm 6 base. What is 648 divided by 3? 216. It makes 216. So how do I evaluate it? This is equal to x. Let's write it as index form. 6 to the power of x is equal to 216. 216 is a special number. I can write it as 6 to the power of 3. So that means that x is equal to 3. Okay, let's solve more questions. Another example. Okay. The question is, again, evaluate. A. Let's make it more complex. Logarithm 3 base 27 plus logarithm 3 base 2 minus logarithm 3 base 6. Now I will try to evaluate first these two functions, then the third function. Now same base, then logarithm 3 base, and addition in between, what will I do? I multiply it, minus logarithm 3 base 6. So that makes logarithm 3 base 54 minus logarithm 3 base of 6. Same base, there is subtraction in between. What do? Logarithm 3 base 54 over 6. That makes logarithm 3 base 9, which is equal to x. Okay, write it as index form. 3 to the power of x is equal to 9. 9 is 3 squared, so x is equal to 2. Number B. Logarithm 4 base 24 minus logarithm 4 base 2 minus logarithm 4 base 6. Now, let's evaluate these two. Same base number, logarithm 4 base, then there is subtraction in between. What do I do? We divide it. 24 over 2 minus logarithm 4 base 6. So that makes logarithm 4 base 12 minus logarithm 4 base 6. Same base number, and there is subtraction in between. Logarithm 4 base 12 over 6. That makes logarithm 4 base 2. That's equal to x. So what is it? Then 4 to the power of x is index form is equal to 2. 4 is 2 squared to the power of x is equal to 2. 2 to the power of 2x is equal to 2. What's the power of 2? 1. It means that power must be equal. 2x is equal to 1. X is equal to 1 over 2. Number C. Logarithm 6 base 78 minus logarithm 6 base 13 plus logarithm 6 base 1. Before I start doing anything here, I noticed that the third function here, logarithm 6 base 1, remember the rule, whatever the base is, if the number here is 1, the result will be 0. So the value of this function is 0. So I got only two functions here. And same base, logarithm 6 base, there's subtraction in between, 78 divided by 13. So that makes logarithm 6 base, that is 6. If these two numbers are same, the result is 1. I don't need to do anything else. Okay, let's make it a bit more complex. So, okay, next question. Again, evaluate. All right, A. 2 times logarithm 5 plus logarithm 4. Now here, the bases are same, 10, 10. However, before we contracted them, there is a coefficient in front of the logarithm. We have to get rid of this coefficient. How do I get rid of the coefficient? I will move it as power. So this is going to be logarithm 5 squared plus logarithm 4. Now, what are the bases here? 10, right? Same base, there is addition. So that's going to be, how can I write it? 5 squared times 4. So that makes logarithm 20 times 4, that makes 100. 5 squared is 25 times 4 is 100. So that's equal to x. What is the base here? 10. So 10 to the power of x is equal to 100. That's 10 squared. X is equal to 2. Number B. Logarithm 3 base 648 minus 3 logarithm 3 base 2. Okay, same base, but I cannot contract them. Why? There is coefficient here. I have to move this coefficient on the top. Logarithm 3 base 648 minus logarithm 3 base 2 cube. So logarithm 3 base 648 minus logarithm 3 base 2 cube is 8. Now, same base, there is subtraction in between. Logarithm 3 base 648 divided by 8. So what is 648 divided by 8? That is 81. Logarithm 3 base 81. It is equal to x. Let's evaluate it. 3 to the power of x. We write as index form 81. 81 is 3 to the power of 4. X is equal to 4. So when we evaluate the whole function, it is equal to 4. Number C. 4 logarithm 10 minus logarithm 80. Okay, again, what are the bases here? Bases are 10, but we have to get rid of the coefficient. Logarithm 10 to the power of 4, it comes as power minus logarithm 80. So the same base, logarithm, then how do I contract them? 10 to the power of 4 divided by 80. So that makes logarithm, what is 10 to the power of 4? 10,000 divided by 80. That makes 125. Logarithm 125. 5. So that's the answer. Number D.